Hello everyone. I hope you guys are doing well. In the last previous some lectures we have studied the particular integration and complementary functions. So we have studied all the cases of the complementary function in the last videos, and we have studied some particular form of the to find the particular integral. Okay, we have also studied in the last videos, like if we have our capital X is equals to e to the power of ax type, or capital X is equals to e to the power cos ax or sin ax. We have studied in the last lectures. So to see these forms, go first these lectures, then come on this lecture. Okay, then you can understand it properly. So if you have the capital X equals to x to the power m form, x to the power m form, then how will you evaluate? What about the working rule? What about the working methodology? Okay, so we have the working rules here for this form. Okay, now bring out the lowest degree term from the f of d, so that the remaining factor in the denominator is of the form 1 plus phi of d to the power n, or 1 minus phi of d to the power n. Just try to take the lowest degree term from the f of d. Okay, then to convert it into this form. After doing this, in the second step, we take this and this in the numerator, so that it can take form as 1 plus phi of d to the power minus n, or 1 minus phi of d to the power minus n. Okay, after that, in the third step, we expand 1 plus minus f of d to the power minus n by the binomial theorem. Okay, we have studied the binomial theorem in the 12th standard also. I am recalling the formulas here some for the binomial standard. 1 plus x to the whole power n equals to 1 plus nx plus nn minus 1 by 2 factorial x square plus nn minus 1 minus 2 divided by 3 factorial x to the power 3n plus dot 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 up to infinity. If we have the binomial expansion of 1 minus x to the power minus 1, then we have the formula 1 plus x square plus x to the power 3 plus x4 plus dot 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 up to infinity. If we have 1 plus x to the whole power minus 1, then we can write it as, if we have 1 minus x to the power minus 2, then we can write it as 1 plus 2x plus 3x square plus 4x to the power 3. All these formulas and this theory is required to work on to find the particular integration of this form. Okay, remember, first you have to understand this theory, then try to solve the questions. Okay, we have some remarks also. Remark number 1: if we have a polynomial in place of x to the power n, in place of x to the power m, if we have the polynomial capital X equals to this, then the same methodology will be done there. Okay, same methodology will be proceed. We will proceed in the same manner as we have done for x to the power m. Okay, now remark 2: d to the power m, x to the power m will be calculated as m factorial. Obviously it is the mth time differentiation. If we have the differential degree is greater than the polynomial degree, then this derivative will also be 0. Okay, remember these two remarks are too important to solve this question. Now we try to solve this question based on this theory. Okay, we have here the constant. For the constant, you know, every constant is a polynomial. Okay, it's a constant polynomial, so we will apply the same methodology here. Now we find out the solution, and to find the solution we need to find the complementary functions and particular integral. Now what about the complementary function? To find the complementary function, we need to find the auxiliary equation, and the auxiliary equation will be divided as m to the power 4 minus m square is equals to 0. Now take m square common to find the factor. It is m square minus 1 is equals to 0, and here we have the value of m, that is 0, 0, and here we have m square minus 1 square, that is 1, and comma minus 1. So we have two repeated roots here and two distinct roots. So what about the complementary function in this case? So it will be, you know, c1 plus c2x e to the power 0 into x, and then plus c3 e to the power x, and then plus c4 e to the power minus x. Okay, this factor is due to 1 and this factor is due to minus 1 and this factor due to these two zeros. So we have this complementary function. Now to complete the solution, we need to find here the particular integration. And in terms to find the particular integration, okay, we need to solve this. Obviously, we have here the polynomial type, okay, 2 into x to the power 0. Now we need to solve it with this theory. So come on, we can take we can write here d square minus d to the power 4 minus d square into 2. Now obviously we need to make here 1. So we will take minus 1 upon d square common. So that 1 minus d square, okay, into 2. Remember, if you see the first step, okay, you will take the lowest degree term common, okay, from your f of d to convert in 1 minus or plus f of d. Okay, now then you can write it as 1 upon minus d square and 1 minus d square. It is your second step, okay, minus 1. Now you can expand it with the help of binomial theorem, as 1 up minus 1 upon d square will be as it is, and expand it. Okay, now you can expand it as 1 plus d square with the plus all the term will be plus because we have minus and minus here. Okay, so all the term will be plus, and 1 plus x square plus x to the power 3, that formula will be applied here. And the remember next term will be d to the power 4, d to the power 6. So we have the 2 here. So 2 means if we apply if we multiply 2 inside, so 1 minus 1 upon d square and 2 will be multiplied in 1, that is 2, and then d square into 2 and then plus dot dot dot. What about this minus 1 upon d square and 2? What about the derivative of the constant term? It is 0, okay, and every term will be 0. Every term will be 0 in this infinite expansion. So you have to work here this smartly. Okay, remember because the derivative powers and powers of the polynomial, power of the derivative is more than the power of the polynomial. So by this property every term will be 0. So you can say here minus 1 upon d square into 2. Okay, so it's your estimate. Now come on, double integrate it with respect to dx. Okay, so first we integrate 2, so it will give you the 2x. Okay, next it will give you the minus 2x square by 2. Okay, so it will be cancelled out. So your pi will be minus x square. So what about the general solution? Simply general solution will be calculated as ca plus pi. We have done this. So c1 plus c2x e to the power 0x means 1. So we will write it as only. Okay, so c3 x to the e to the power x and plus c4 e to the power minus x. What about the pi, that is minus x square? It is your final answer. So guys, we have the simple steps to follow here to find the solution, required solution. Okay, now come on, to understand this theory we need to solve some more question based on this theory. And now the next question is to discuss here. Find the solution for the equation for the differential equation d square plus d and y is equals to x square plus 2x plus 4. We need to solve this question. Okay, so guys, come on, to solve it first we need to find auxiliary equation for the complementary function. So what about the auxiliary equation? It will be decided by m square plus m is equals to 0. So now take m common, you can write here m plus 1. Okay, so you have the two factor here, 0 and 1, both are the distinct real roots. So your complementary functions will be decided as c1 e to the power 0 into x and plus c2 e to the power 1 into x. So your cf will be as c1 plus c2 e to the power x. Now for pi, to find the pi, you will obviously you have to calculate d square plus d, and here you have the quadratic polynomial x square plus 2x plus 4, right? So now what you have to do, first try to make it of the form 1 plus f of d. So you will take the lowest degree term common, that is d. Take the d as a common, so you will have 1 plus d here, 1 plus d here. So you will be calculating as x square plus 2x plus 4, and that is 1 upon d, and 1 upon d can be written as 1 upon d minus 1, okay, and x square plus 2x plus 4. Now you need to expand this binomial expansion. We have plus here, minus here, the terms will go alternatively, 1 minus d plus d square and minus d to the power 3 and plus d to the power 4, and there is no need to write the also d to the power 4 and d to the power 3, because d to the power 3 is greater than the 2 degree of this quadratic polynomial. So d to the power 3 will make the complete term 0. The third time derivative of this will be 0. Fourth time derivative is also 0, and the higher derivative for this will also be 0. So there is no need to write these terms. You can write only up to the two terms, up to the degree of the polynomial. Okay, so 1 upon d, 1 minus d and plus d square, you can write it here up to here. Okay, now come on, 1 upon d and multiply this term into 1 x square plus 2x and then plus 4, then minus derivative of this, d means first derivative of this, so it will be as 2x and then plus 2, okay, and then plus double derivative of this means again derivative of this, and this will be 2, okay. Now it is the final, and the rest of the derivative will be involved as 0. Now what about the results? So we have the final result for the pi as 1 upon d. Now come on, find this. So you can write x square, and you have here plus 2x and minus 2x, so these will be cancelled out. So 4 plus and minus 2, so this plus 2, this minus 2 and this plus 2 will be cancelled out, so we have the 4 here, okay, 4. So now come on, 1 upon d means integration, so we have the integration of x square plus 4 dx. Now come on, solve it. X squared integration means x to the power 3 upon 3, and 4 integration means 4x, okay. And in pi, remember one thing, there is no terms of, no constant will be added here, okay. Don't try to constant edit here. In the pi, it is always constant free. So what about the general solution? So general solution will be written as the complementary function plus particular integral. So what about the complementary function? We have calculated here, that is c1 plus c2 e to the power x, and plus what about the pi, x to the power 3 and then plus 4x, which is the required answer. Okay guys, we have the very simple steps to follow, okay. So now come on, we need to solve the one more question based on the theory. So I would love to solve d to the power 4 minus a to the power 4 y is equals to x to the power 4. Come on, we need to solve this, okay. So obviously first I will find the auxiliary equation. So my auxiliary equation will be written as m to the power 4 and minus a to the power 4 is equals to 0. So now you can apply here the formula of you can write here m square a square minus a square whole square equals to 0. So you can write here m square minus a square and m square plus a square by the formula. Which formula we have applied here? A square minus b square equals to a minus b and a plus b. Okay, with this formula you can write it as. So come on, again you can apply here the formula m minus a and m plus a. Okay, and what about this? Obviously you can write it as plus minus iota. Okay, you can write it as m square minus iota a square, right, equals to 0. So you can write it as minus a m minus a m plus a. Okay, and m plus iota a and m minus iota a. Okay, or so you have the roots here, a minus a and plus minus iota a. So what about the complementary functions? Two roots are real and distinct and two roots are in complex conjugate pair. So CF will be decided as C1 e to the power ax and plus C2 e to the power minus ax and plus e to the power 0 into x and C3 cos ax and plus C4 sin ax, right? Then you can write here C1 because e to the power, okay, e to the power ax and then plus C2 e to the power minus ax and then e to the power 0x means 1. So you can write here C3 cos ax and plus C4 sin ax. It's your complementary function, right? We have done it in the simple steps. Okay, now for the particular integration we need to calculate 1 upon d to the power 4 minus a to the power 4 x to the power 4. Obviously, as I have stated all the rules to find the pi. So first of all, take the lowest degree term outside to convert it into the 1 plus f of d form. So take minus 1 upon a to the power 4 as common from the denominator. So you will have here 1 upon 1 plus d 1 minus d by a. Okay, d by a to the power 4, d upon a to the power 4. Okay, x to the power 4. Because minus a to the power 4 you have taken common, so minus you have here 1 and minus d upon a to the power 4. Come on, now apply the second step. So 1 upon a to the power 4, you can write it as 1 minus d upon a to the power 4, okay, to the power minus 1 and x square. Now come on, now you can write minus 1 upon a to the power 4 and you can apply the binomial expansion here if you consider it as x. Okay, so you can write, because here minus minus, so we will have all the sign as plus. So 1 plus x, right? 1 plus x means d by a to the power 4 and then x square means d to the power 8 and we have x square. So x square, this expression will make x square 0 and the higher order from this all the terms will be zeros. So no need to write the further expansion for this. Now multiply by x square. So minus 1 upon a to the power 4 multiply by x square inside, so you will get x square and plus d to the power 4 upon a to the power 4 into x square. Okay, and then so minus 1 upon a to the power 4 and you will get here x square and this derivative is 0. And not only this, all the rest derivatives are 0. So we have the pi here minus x square upon a to the power 4. So we have the general solution here, CF plus pi. CF is C1 e to the power ax plus C2 e to the power minus x plus C3 cos ax and plus C4 sin ax and minus x square upon a to the power 4. So which is the general solution and final solution. Okay, Similarly, I think we have done some mistake here because we are having here x4. So there should be x4, not x square. It should be x4, okay, and it should be x4. So what about this? What about this? It should be 4 factorial upon a to the power 4, okay, and means it should be plus 24 upon a to the power 4, okay, because 4 factorial is 4 into 3 into 2 into 1, okay, and it should be finally x4 here, okay, it should be x4, okay. So x4 plus 24 upon a to the power 4, which is the required answer for your given questions. Okay, so guys, we have the simple steps to follow here, and I would love to explain the another question to understand this theory of the different variations. So now the next question I have here, d to the power 3 plus 8 y is equals to x to the power 4 then plus 2x and then plus 1. Now come on, we need to solve this situation here. To find the complementary function, first I would love to find the solution, okay, and for the auxiliary equation we have m to the power 3 plus 8 equals to 0, or you can write it as m to the power 3 plus 2 to the power 3 is equals to 0, and you can expand this formula as m plus 2 and m square minus 2m plus 4 equals to 0, right? So now what about the rest root for this? So we have m plus 2 equals to 0 and m square minus 2m plus 4 equals to 0. So we can apply here Sridharacharya minus b, okay, and then plus minus square root. B square means minus 2 square 4 minus 4, value of a is 1, value of c is 4, divided by 2 into 1, okay. So you can write here 2 plus minus square root 4 minus 20, that is minus I think it is 16, 4 minus 16, that is 12, right? It is 12 divided by 2, okay. So you can write here 2 plus minus iota 2 iota square root 3 divided by 2, or you can write it is plus 1 plus minus iota root 3. So which is the complex conjugate root. So your complementary function will be decided as CF is equals to, remember we have the formula a to the, we have applied here formula a to the power 3 b to the power 3 equals to a minus b, and a square minus ab and plus b square, okay. This formula we have applied here, okay. Sorry, a plus b, not a minus b, a plus b and a square minus ab plus b square. So now the complementary function will be, we have the m1 real root, m equals to minus 2, so c1 e to the power minus 2x, and then plus e to the power 1 into x, because we have the value of alpha is 1 and beta is equals to square root 3, so e to the power 1 into x, and cos square root 3x, and plus sine square root 3x, right? So we have this CF. Now for the particular integral, we find as 1 upon d to the power 3 plus 8, right? And x4, then plus 2x, and then plus 1. So we take lowest degree term as a common, that is 1 upon 8. So it will be 1 plus d by 2 to the power 3, okay. It will be x to the power 4 plus 2x. We have the 4 degree biquadratic polynomial here. So we have 1 upon 8, and you can write it as 1 plus d by 2 to the power 3 to the power minus 1, and x to the power 4 plus 2x. Remember one thing, we will expand it, but not the power greater than 4, not up to the power greater than 4. We will try to expand it equals to 4, d to the power equals to 4 or less than 4. So 1 upon 8, we have plus here, minus here, so sign will go alternatively. 1 minus x means d by 2 to the power 3. Okay, and this square means x square means d by 2 to the power 6, which will be the power will be the greater than the power 4, x to the power 4. So it will perform all the zeros. Okay, so come on, next term there is no benefit to write them. Okay, so x4 plus 2x plus 1. So now we have the resultant 1 upon 8 and 1 minus d to the power 3 by 8 and plus dot 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 and x square plus 2x and then plus 1. So come on, 1 upon 8 multiply by this inside x to the power 4 and then plus 2x, okay, and then plus 1 and third time derivative. So third time derivative, this will give you 4 into 3 into 2x, okay, and the derivative of the rest term will be 0. Okay, so you have 1 upon 8 common, x to the power 4 plus 2x and plus 1 and then minus, it is 4 to the 8 and this 8. So here we have the minus 3x. Okay, finally we get 1 by 8, okay, x to the power 4 minus x plus 1. So it is your pi. So general solution will be decided as c1 e to the power minus 2x then plus e to the power x and cos square root 3x plus sine square root 3x and then pi will be as 1 upon 8 x to the power 4 minus x plus 1. It is your general solution. So guys, you have the number of questions to solve, number of method to solve here, and I hope you guys can understood each and every topic properly. So see you in the next video with the next variation to find out the pi. Thank you very much. And final, in the last, I will request each and everyone to like, subscribe and share the videos among your friends so that everyone can be benefited with these videos or with these lecture of series. So come on, subscribe, like and comment. Thank you.